Okay, we're here today to demonstrate how to use Ansys Electronics Desktop in Ansys Cloud using a new VDI browser technology. Here we're at the Ansys Cloud login page, and I'll go and sign in. This will take me to my sign-in page. I'll click my sign in, and it already has my password cached. If you're using this for the first time, you'll be asked to put in the password that you provided with your cloud subscription. I sign in, and this takes us to the Ansys Cloud portal. Now, the dashboard itself just kind of represents information about what you're using on the cloud. Right now, I have a brand new clean cloud account. I have no jobs running, no files saved. So for this process, what I want to do is I want to launch a browser-based interface for the Ansys Electronics Desktop to run an HFSS simulation using Ansys Cloud. And to do this, I go to Applications on the left-hand side, and I get a number of options to run. They're related to the various Ansys applications available on the cloud, and in particular, I want to run an AEDT, or an Ansys Electronics Desktop session using a browser. So I click this option for in-browser interactive session, and then I'm brought to this dialog. Now here in this dialog, I'm going to pick what version of the software I want to run, as well as define the type of hardware I want to run the software on. And then I'm going to ask to define a folder for where I'm going to save my projects when I'm running them in the cloud. Okay, once the sessions are loaded, I'm going to pick my version, which will be 2020 R2, the current version for Ansys Electronics Desktop. And then I'm going to pick my hardware configuration. There's a number of configurations to pick from. I'm going to pick this HC 44 core configuration. And this essentially means I'm going to be running the Ansys Electronics Desktop on the equivalent of a 44 core workstation. The last step I need to do is I need to select a folder on the cloud where I'm going to save the projects and simulation results. So I browse to a folder and I identify what geographic location for the cloud that I want to run this simulation and save the projects to. I'll select the East Coast US. And once this comes up, I'll ask to create a new folder. I'll name this folder HFSS Simulations, create. Now I've created this folder, I need to select this folder. Once I have it selected, I click Select Folder, and now I'm ready to go. I've picked my region, I've picked my version, I've picked my hardware configuration, and I've defined a folder on the cloud where I'm going to save my projects along with their results. And now I'll click Start Session. Okay, once the cloud VDI machines have come up and the software has been installed, inside the browser, you're looking at a typical Windows desktop. You got your icons on the left-hand side representing the various applications you can run. And in this case, we're going to run the Ansys Electronics Desktop, or this green EDT icon. So I double-click on this icon, just as I would on my own laptop or own workstation, and this will bring up an Ansys Electronics Desktop. I have an option if I'm interested in going to the full screen mode. And notice in the full screen mode, as it appears, it's like I'm working in any other electronics desktop session. It might as well be right at home here with me on my laptop. For this example, just to demonstrate how I can run a simulation on this Ansys Cloud workstation, so to speak, I'm going to go to File, Open Examples. I'm going to grab one of the antenna examples, this 5G substrate integrated waveguide antenna. And this brings up this example project. And as with any example project, this project is residing in the installation folder for the Ansys Electronics Desktop, which is write protected. So these example project files can't get written over. So before I run a simulation on this project, I want to save this project to my directory that I created for saving and simulating my project. So I go to File, Save As, and it's going to bring up a browser. If I go to this PC, and I just scroll down, I'm looking for this drive, Temp Storage D, and inside this Temp Storage D drive, which again is on the cloud, will be a second folder, which will be called the Ansys Cloud Drive. So I'll click in there, and I'm going to save my project right here. So in effect, where I'm saving my project, and here it's asking me to save the help PDF that comes with the example project, So in effect, where I've saved this example project is on that folder that I defined earlier when I first launched the cloud session. So from here, it's like I'm working in any other Ansys HFSS Electronics Desktop session. I can do things like I can add designs to the project. I can draw geometry, the cylinder, draw a box. I can take those two objects and unite them. And notice the responsiveness is very, very nice. It's very, very clean. I can really detect almost no lag between working in this interactive cloud session and compared to if I was working on my own laptop. So it's just like any other Ansys HFSS session. You can do all the different commands. You can grab 3D components, for example, from the install. Everything's the same in that regard. So I'm just going to go ahead and just delete this example design because we don't need it. I don't want to save that. And I want to say, yes, I really wish to delete it. And I'm going to go run this project here, which is a 5-element 5G array in a substrate integrated waveguide topology. So again, looks just like any other HFSS session. So I go to the analysis branch, I go to the setup, I right-click, and I go analyze. Now again, just like any other HFSS session. So here it's going to spin up the simulation and launch it. And if I go to the view, I can bring up the message manager per normal. I can bring up the progress bar per normal and resize those to get a better image of the modeler. I can observe the progress bar. I can look at the profile. So here you see it's just gone into adaptive pass number 1. And if you're curious, how many cores is it running on this workstation? Well, since I didn't do any special settings, it's just going to do the default 4 cores. And in a second, I'll show you how to set it up for additional cores. So here we are in adaptive pass 2. We can look at convergence, look at the number of solved mesh elements, look at matrix data. So again, just like any other normal HFSS simulation session. Okay, now once my simulation is finished, in this case, this simulation took 3 minutes and 22 seconds, I can close my profile dialog. I can come into my results branch, and I get the same set of results again per normal. I have gain plots, a variety of gain plots, and these are already post-processing plots that were created with the example project. If I want to, for example, overlay this gain plot in the modeler window, I can right-click on the gain plot and go to that option. And in a second, you'll see that far field plot's overlaid in the modeler window, but it's not overlaid where I want it to be. But again, just like any other HFSS session, I can go to that far field definition, go to properties, go to coordinate system, pick the center coordinate system on the middle of the array, apply it, and there's my overlay of my far field pattern on the antenna. I can even do things like go to plot fields, radiation fields, set transparency, let's make it opaque, let's make it a little bit larger. And again, just like any other session with HFSS. I have some field plots that are created. Bring those up. Hide that far field plot so we can see them. I can animate these plots. And again, just like any other HFSS session, but in this case, I'm in my browser working on Ansys Cloud, working on this 44-core workstation. I'm going to go ahead and close down this animation and just show you what you would do if I wanted to. You want to get access to more of these cores in the base 4 that come with HFSS. So I can go to Tools, Options, HPC and Analysis Options, and I can add a new configuration. And I'll just call this, let's see, we'll make this a 24-core configuration. I'll add local machine. I'll define 24 cores. I'm not going to use GPUs. And again, I'll use automatic HPC settings. I'll click OK. I'll make this configuration active. Click OK. And then I'm going to make a copy of this design. Paste it in the project. And then run the simulation as normal. So again, here you see the progress bar, setting up, getting ready to run the simulation. Message manager, just like normal. Let's go ahead and go to the results tab on the ribbons. Look in the profile. And here you see the simulations using 24 cores, just as I set up that configuration. So again, it's just like any other simulation, any other session with HFSS, whether it's on your laptop or your workstation. The difference here is I'm working inside my browser, running on a workstation in the cloud, a virtual machine in the cloud. I'm just going to go ahead and close down this profile and just abort this simulation for now. And then the next example I want to show you is, let's say I want to run this simulation on a much larger set of hardware than the 44 cores that I got with this configuration that I defined for my interactive session. Let's say this is a bigger simulation, a much bigger simulation that I'm looking at here, and I want to run it, say, on 88 cores or more cores than I have on this local machine. Well, I can do that as well. So what I'm going to do is I'm going to grab a different example project, a little bit more complicated. Again, back into antennas, and I'm going to take this finite array antenna project that is actually an example of our 3D component array design capability in HFSS. So this is a very simple representative array design. It's just 2x2 multi-cell element array. If I do a downward view, I've got 2 patch antennas, some empty space, and then a radome. If you look at it on the side, you'll see the radome structure. And you can do things like, again, interactive, click and drag, hide some of the features, just look at the objects that are just in the simulation. So to run this simulation, I want to use more than the 44 cores that are available on this cloud instance, this cloud virtual machine that I use for my interactive session. Well, to do that, I'm just going to set up the cloud as my remote simulation engine. So to do this, I go to Tools, Submit Job, and then select Scheduler. Now the default scheduler that comes up when you install HFSS is RSM. So here I'm going to select a different type of scheduler. I'm going to select Ansys Cloud. When you pick Ansys Cloud as your scheduler, you're asked to log in. And this login will be the same login that I use for the interactive session. But now you see what I'm doing is I'm sitting in an interactive session on the Ansys Cloud using my browser. And now with this setup, I'm going to go out and access more machines on the cloud somewhere else to run my simulation remotely. So this will bring up a login page. It'll ask you for your account. In this case, it is my email address. Then I enter my password. And I sign in. Okay, with that, we're logged into the cloud for our remote machines. And as with any instance of running a simulation remotely on the cloud, you'll run it the same way here with this VDI interactive browser session. So we'll go to the analysis setup, right-click on the setup, but instead of doing an analyze, which would solve this project on the local hardware, the interactive VDI machine hardware, we'll do submit job to launch it elsewhere in the cloud. That brings up the cloud dialog. You go to the Compute Resources tab to pick your hardware. Maybe you want a different type of hardware than the 44 core for the virtual machine. You go to some larger HC configurations like the medium configuration, which is 88 cores and 2 nodes, or there's some other hardware you can pick from, perhaps that's more economical, such as the H machines, maybe an H large, which gives you 128 cores across 8 nodes. That picks your hardware. You then want to define a job name for running the simulation, and you click Submit Job. And that launches the simulation out in the cloud as you would from your laptop or your workstation. So today we demonstrated to you how to bring up a VDI browser session to run Ansys Electronics Desktop in the cloud, how to set up a simulation, how to run a simulation on that VDI browser session, as well as how to use that same VDI browser session, that interactive session with the Ansys Electronics Desktop, to run a remote simulation to other resources on the Ansys Cloud. Okay, now after we've launched the simulation to the cloud, we can come back to the Tools, Job Management, Monitor Job menu, and go see how the cloud is the solution on the cloud is performing. If you go to the Recent Jobs pull down, that will actually show up what was the last job you launched to the cloud. Since this is a cloud session, this is the only time I've been on the session, so this is the only job I've run. So I select that run. And then this dialog, which is a standard dialog for doing remote monitoring for jobs submitted to HPC clusters or remote simulation machines. This will actually monitor on the cloud what the status of the simulation is. And in this case, the simulation is completed. It's given us a job status of completed, which is great. And so what we can do now in this portal is we can go to our download pull down here in the lower right-hand corner, and we can download a set of results. Now we have some options. We can download the full results to be the full project. If we also had exported S parameter files after simulation, we can download just S parameters, as well as some very specific solution files that we would define before setting the simulation. But in this case, we're just going to grab the entire results. So we'll go download results, and we'll get this dialog. It's basically what it's doing is it's going back to those cloud machines where it did the remote simulation, it's packaging up the solutions into an AEDTZ archive file, and now we're complete. So this is a fairly small project, downloaded pretty quickly from the cloud. So we close this dialog. Okay, how do we go find the results? Well, we'll go to File, Open. We'll browse to the directory on this remote VDI session where we asked to save our project, which is the temp storage D directory. We go to Ansys Cloud Drive, and here's the project that we launched and simmed to the cloud. You'll notice in this dialog that there's a couple of additional folders, and I'll talk about those in a moment, but this particular project doesn't contain the results. This is actually the project that we launched. Where the results were downloaded to is actually going to be in that .aedt download folder. And if I browse into that download folder and I go into, this is actually the ID of the cloud job that we just ran. If I browse into that folder, you'll find an archive project, an AEDTZ project in that folder. Some other info that you can use to look at how the simulation ran. But what we're inside this archive is the project, the design with the results that we just solved on the cloud, and you just saw me download from the Monitor Jobs dialog. So I'm going to open up this archive. So like with any archive, it's going to ask me, hey, where do you want me to save the project? I can save that project anywhere. So what I'll do, I could save it here inside this downloads folder. Maybe what I'll do just to sort of keep things a little organized is I'll just create a new folder back at the level where I had the original project. I'll just call it Cloud Results. You don't have to do it this way, but this is just a way for me to sort of keep track of all the results. And I'll just unzip the project solved in the cloud, zipped back up, downloaded to here into this directory. So again, this is the AEDTZ file with the results that we just ran on the cloud. So I close that. So standard as in with any AEDTZ file, here's my design. I look in my design. Now let's take a look at things like results. I go to solution data. And you see you got matrix data, convergence information, profiles. So this was the simulation that was just solved on the remote machines on the cloud. So if I go into my design, I can look at S parameter results, pretty typical stuff, gain plots. These were result plots I had created before running the project, and even field overlays. So I can look at, these are overlay field plots I created before running the simulations. Okay, and if you want to get an appreciation of the responsiveness of this desktop session in the VDI browser session in the cloud, let's just do an animation of one of the field plots here. So I'll just take this plot definition, right-click, go to animate. We already have a definition defined of an animation with respect to phase. We'll click OK. And you'll see in the lower right-hand corner, you see the green progress bar going by as it creates the frames for the animation. And you see you can just observe animations right here on a remote session to the cloud as responsive as if you're running the thing locally on your laptop. And as you can see, you can speed up an animation just like normal as if you're running this, doing this post-processing locally on your laptop. So you see, the great thing that I've demonstrated here is I've working from a remote VDI session, an in-browser session of the Electronics Desktop running HFSS. I've decided that for this simulation, I wanted more horsepower, more resources. I launched it out to other remote machines on the Ansys Cloud, and I've brought those results to my VDI browser session, and I post-processed them here. All right, so there you go. Thank you very much for joining this session on using Ansys HFSS in the Ansys Cloud.